Everyone. So today we're going to discuss two topics in dynamics of rigid bodies, which are rectilinear motion and vertical motion. So to begin with, let's start with rectilinear motion. So rectilinear motion by definition is a physics concept that describes the displacement of an object in a straight line without a change in direction. So formulas for rectilinear motion, we have two categories. First, we have the constant acceleration, and second, we have the variable acceleration. So let's start with constant acceleration. First, we have S is equals to V sub 0 times T plus 1/2 AT squared. Next, we have V is equals to VO plus AT. V squared is equals to VO squared plus 2AS. Where S here stands for displacement and VO or V sub 0 stands for the initial velocity, and T here stands for the time, and A stands for acceleration, and V stands for the final velocity. Next, we have the variable acceleration. So this acceleration is erratic, wherein in a given amount of time, the variable are changing. It's either increasing or decelerating. So these equations are derived from the distance formula or the displacement formula. So the first derivative of the displacement formula is equals to V is equals to ds over dt. And the second derivative or the first derivative of V is equals to A is equals to dV over dt. And cross multiplying these two equations, we can form this last formula, which is V dV is equals to AdS. So that's the formulas for rectilinear motion. These are so essential for solving the problems by familiarizing these equations or formulas. Here we have some principles of rectilinear motion. First, when the object moves in a constant velocity, the acceleration would be 0. So when an object moves and its velocity is not changing, basically there is no change in velocity in a specific amount of time. So there is no acceleration. Either the car is not speeding up or it is not slowing down. Second, when the object moves in a constant acceleration, the velocity will vary. So in velocity, when applied with constant acceleration, it will not be 0. That's not the case with the velocity. So when an object is being applied with a constant acceleration, the velocity of an object it's either going up or going down. The vehicle might be going faster or getting slower, because the acceleration will cause the object to speed up in a specific amount of time, or it will cause the object to decelerate in a specific amount of time, causing the object to slow down. So the principle in the velocity and acceleration is not the same. In acceleration, when applied with a constant velocity, it will be 0. But in velocity, when applied with a constant acceleration, it will vary, because the velocity might be going up or going down. So with these principles and formulas, also the concept, we can able to solve some practice problems about rectilinear motion. So let's start with it. Let's apply our knowledge or the concepts and formulas we have learned earlier. Let's solve some practice problems. So problem number 1. We have here, what is the acceleration of the body that increases in velocity from 20 meters per second to 40 meters per second in 3 seconds? So first, let us write the given. We have the initial velocity 20 meters per second, final velocity 40 meters per second, and time t is equals to 3 seconds. What is asked in the problem is the acceleration. So, since we are given with initial velocity, final velocity, and time t, we can use the second formula, which is v is equals to VO plus AT to find the acceleration. So substitute the values. V, the final velocity, is equals to 40, is equals to 20, the initial velocity, plus the acceleration, which we are finding, times 3. So the acceleration is 40 plus 20 plus 60.67. 6.67 rather, m squared. So this is the answer. Next problem. Problem number 2 we have here. How far does an automobile move while its speed increases uniformly from 15 kph to 45 kph in 20 seconds? So let's write the given first. We have initial velocity 15 kph, final velocity 45 kph, and time t, which is 20 seconds. So the problem here wants us to find how far, or the distance it travels, as since these variables are not the same, we are going to convert kph to meters per second. So VO first, or the initial velocity, 15 kp over h. So kilometer per hour. So 1 kilometer is equals to 1000 meters, and 1 hour is equals to 360 seconds. So this will cancel this also. So 15 1000 over 360. So 4.617 ms. Next, the final velocity. Same process. 1000 meters, 360 seconds, 3600 rather, 1 hour. This will cancel, also this. So the answer would be 12.5 meters per second. So since now we have the same variables, we can perform the formula for finding S, or the distance traveled or displacement. Since we are given the initial velocity and the final velocity, we can use the third formula or equation, which is v squared is equals to VO plus 2AS. But you can notice that in the problem, the acceleration is not given. So we're going to solve for the acceleration first. So we are given the initial velocity. We are given the initial velocity, also the final, and we have time t. So to find the acceleration, we will perform the second equation, which is v is equals to VO plus AT, where VO is, let's use the converted values. So 12.5 is equals to 4.17 plus A, which we are finding, times time 20. So A is equals to 12.5 4.17 plus alpha x times 20. So the acceleration would be 0.4165 meters per second squared. So since we have all the values that we can plug into this equation, so let's just substitute it to the equation. So v squared 12.5 squared is equals to 4.17 squared plus 2, the acceleration that we recently get for 0.4165 s. So finding for s, have 12.5 squared 4.17 squared plus 2, 0.4165. So s is equals to 166.7 meters, or s is equals to 167 meters in, if we rounded it off. So that's the answer for problem number 2. Next we have problem number 3. So it states that determine the velocity of the progress with given equation d is equals to 20t plus 5 over t plus 1 when t is equals to 4 seconds. So notice that this problem gives us the equation of the displacement or the distance, and we are going to find the velocity with respect to t, and t here is the time. So let's make let's write the given. So we are given an equation d is equals to 20t plus 5 over t plus 1. So, and also we are given time t 4 seconds. So we are asked to find the velocity. So to make this equation in terms of to make this equation to become a velocity formula, let's have the first derivative of this equation. So the first derivative of, as we recall, those in acceleration variable equations are derived from the displacement equation. So the first derivative of this is the velocity. So 20t, first derivative of 20t is equals to 20 plus, since this is in fraction form, we're going to perform the v du minus u dv over v squared. So v is equals to t plus 1, derivative of a constant is 0, minus u 5 times this equals to 1 over v squared. So simplifying, 20 plus this will cancel out into 0, so negative 5 t plus 1 squared. Further simplification, 20 minus 5 over t plus 1 squared. So now we have the velocity equation. We will plug in. Now we were going to plug in the given time to have or to get the answer for the question and determine the velocity in a given equation. So v is equals to 20 minus 5 over t wherein t is equals to 4 plus 1 squared. We have the answer now. 20 minus 5 over 4 plus 1 squared. 19.8 meters per second. So this is now the answer. So just remembering the concept of the variable acceleration and the derivatives from the acceleration, from the displacement formula, we can perform it by substituting the given values of time. We can locate or we can find the value of the velocity. Next topic, we have the vertical motion. So vertical motion by definition is the movement of an object in a straight line, either in an up and down direction under the influence of gravity. So formulas for vertical motion is similarly identical to the rectilinear motion. So only one variable differs. So let's dig up. So S is equals to V sub 0 times T plus or minus 1/2 GT squared. So the signs I will discuss later. V is equals to VO plus and minus 80. V squared is equals to VO squared plus and minus 2AS. V is equals to ds over dt, and A is equals to dv over dt, and vdv is equals to ads. So the same values from rectilinear motion, the same variables, only the acceleration. In this topic, the acceleration we are considering is due to gravity. So the acceleration we are using is, instead of A, we are using G. So let me correct this. G. Okay. So some principles of vertical motion. So the same set of formulas for rectilinear motion. So as we are seeing, we have the same formula, only the acceleration is changed. The acceleration may vary with respect to the motion of the object. So that's why I emphasize the signs of for every equation, because if the motion of the object is along with the gravity, the acceleration is positive. But if the object's motion is against the gravity, the acceleration is negative. That's why I emphasize the plus and minus in every equation. Next, when the object is dropped, its initial velocity is 0. So imagine dropping something. Its initial point where you hold it, there's no motion or there's no velocity. That's why it is 0. It's the same concept of the free falling bodies. Also, if the object is thrown upward, the velocity at the highest point of its motion is 0. So if you throw a ball upward, it will reach its maximum height. Because if there is no gravity, the ball or the object will go upward. But because there is an gravitational pull, or the gravity itself will cause the velocity or the ball or the object to slow down until it reach its maximum point. That's why That's why when it reaches its maximum point, the initial motion will be upward, but when it reaches its maximum point, it will begin to zero and it will go into drop or in a free falling motion. That's why the same concept of dropping a ball and reaching throwing a ball to the top and reaching its maximum point, it will also drop. So it is the same concept of dropping a ball in a height and reaching its maximum point by throwing a ball, and its motion will change into falling. So that's the principle or the concept of vertical motion. So without further ado, we are going to solve some practice problems to dig deeper of what is vertical motion. So we have a problem here. Problem number 1. A ball is dropped from a building 100 meter high. If the mass of the ball is 10 grams, after what time will the ball strike the earth? So, analyzing the problem, we can make an illustration. So, let's write the given first. Given. We have the height of the building, 100 meters. Also, we have the mass, 10 grams. From the problem, we can draw an illustration of a building (100 meters high) and the ball is being dropped. This is the ball to the ground. So we are going to find the time it takes for this ball to reach the ground. So using the given, we can find the time. So we know that at this point, the initial velocity is equals to 0. So we can solve for t using the equation s is equals to VOT. So we are going to use positive sign because the motion of the ball is going downward and the acceleration due to gravity is also going downward. So I am emphasizing that this is a plus sign. So 1/2 g t squared. So the distance from the datum, the distance from the ground, or the distance where the ball is dropped from the ground, is 100 meters. And the velocity of the ball, its initial velocity before being dropped, is 0. And t is the variable that we are finding. 1/2 9.81 t squared. So solving for t is equals to t is equals to 20.39 seconds. Next problem. Here we have problem number 2. A ball is dropped from a roof of a building 40 meters tall. Will hit the ground with a velocity of. So lately we are in the previous problem we are to find the time. Here we are to find the velocity. So first we are going to write the given. First we have the height the building, 40 meters, and yeah, that's the only given. So from the problem, we can also draw an illustration. A ball is dropped from the roof, so there's a roof of a building 40 meters tall. So if this is the building and this is the roof, so this is 40 meters. Here's the ball. What is the velocity if it will hit the ground? V. So we know from the concept of free fall that the initial velocity before it goes into a motion or drop is 0. So with a given distance from the ground or given distance where the ball is being dropped, we can use the equation v squared is equals to vo squared plus 2as. I'm going to use plus sign again because the motion of the ball is along with the motion of the gravity. So I am using plus sign. So v squared is what we are finding, and v sub 0 is equals to 0 squared plus 2, 9.81, and the distance 40. So v is equals to so the velocity is equals to 28.01 ms or meter per second. Okay. Next, we have problem number 3. Oh no. Using a powerful air gun, a steel ball is shot vertically upward with a velocity of 80 meters per second, followed by another shot after 5 seconds. Find the initial velocity of the second ball in order to meet the first ball 150 meters from the ground. So this problem is tricky because it has a lot of given and a lot to be considered. So first we have to write the given. Given we have initial velocity of the first ball VO is equals to 80 meters per second, and the time the second ball is being shot, T is equals to 5 seconds. Also, the height of the second ball that the first ball will meet, H is equals to 150 meters. So to fully understand on how to solve this problem, you are to make an illustration or a drawing on how to solve this. First, we have a gun here, this point, and shot a steel ball upward with a velocity of VO is equals to 80 ms. Also, another shot is fired 5 seconds after the first one. T is equals to 5 seconds. And the condition of the second ball is that they will meet 150 meters from the ground. So we are going to find this motion here. This is the apex or the highest point that the ball can go. This is its height and the time that they will meet here. So we are going to divide by section and solving it and find its values and plugging it together to find the time or the velocity of this ball. First, we are going to solve the time it takes for the first ball to make to this point. So we know that this point VO is equals to V final. The V final for this is equals to 0 because it is the highest point of the ball can go before it changes motion to downward path. So we can solve for the time of that. First, we have V is equals to VO minus 80 because the gravity's motion is downward and our ball is going upward, so it is a minus sign. VO 0, initial velocity 80 minus 9.81, can find for T1 time 1. 0, 80 minus 9.81. So the time 1 is 8.15 seconds. Next, we need to find this height for us to solve for the next portion and get the time. So we have now we have the initial velocity, we have the final velocity, we have the acceleration, so we can solve for the height. So V squared is equals to VO squared minus 2AS. Minus again since the motion of the ball is against the motion of the gravity. So V squared 0 squared is equals to 80 squared minus 2 9.81. S is equals to 0 squared 80 squared minus 9.2 times 9.81 times x. So the height of this, the height from the ground to the apex of the ball is 3.26.20 meters. So we have now the height of the apex, and we are going to subtract it from the height of this to get the time to this point. So S is equals to VOT plus 1/2 GT squared. G, this is G. So I am going to use plus sign because the motion of the ball from this apex in this point to this point is along with the motion of the gravity. So S equals to 326.20 minus 150. VO is equals to 0. It's okay to not write that. 1/2 9.81 T squared. So T2, this is T2, and minus 150. 1/2 9.81. So T2 is equals to 6 seconds. So to solve for time that we'll use the time that we'll use on this ball, are going to equate T3 is equals to T1 plus T2 minus T. So T1 8.15 plus 6 minus 5. T3 is equals to 8.15 plus 6 minus 5. 9.15 seconds. So now we are given the time that we'll use to this ball. We can solve for its initial velocity. So S equals to VOT minus 1/2 ET GT squared. I am going to use 1 minus because the motion is going upward, yet the motion of the gravity is going downward. So S 150, VO, the variable that we are trying to find, 9.15 minus 1/2, 9.81, 9.15 squared, VO is equals to So VO is equals to 61.27 ms. So that's the answer to this problem. The technique for solving this problem is to divide it by section and finding the appropriate values to substitute to the equation. So that's it. Thank you.